Hello friends, in our previous video sections we have seen all the set operations represented by using Venn diagram. So now we are going to study some examples to understand some examples. Okay, so first example is, first let A equals to in braces phi comma B, braces complete. Construct the following sets. First, here first question, a minus phi. So here a set contains phi comma b. There are two elements which are in a set. Okay. Next, here ask for a minus phi. A minus phi. Phi is a null set. Here phi is a not a element. It is a null set. Okay. So a minus phi means all the elements of a but not in phi. Phi is a null set already. So 0 elements means all the elements of a. So answer is a. A means phi comma b. There are two elements. So here a minus phi equals to a equals to the value total number of elements in a phi comma b. Okay, phi is the elements in that set a. Okay, it is not a null set, but here phi is a null set. Okay, only phi written here. Second, in braces phi minus a means in braces phi minus a means this is a set which contain phi. This is a set because the phi which are written in the braces. So this is a set minus a. Okay, so this set contains 5 elements, one single element, and a set contains there are two elements phi comma b. There are two elements. So phi minus means a minus b means all the elements of a but not in b. So a which are also in, so phi, the first elements of first set a phi which are also belongs to a. So cancel. So the first set which contains only single elements, there are no any extra elements, so that means the answer is null, phi. Okay, b contain extra element, but here phi minus this set minus a means only single elements, means the answer is phi. Okay, so this set, these 5 elements which are also in a set, that's why the answer is null set, phi or these braces. Okay, next, third example, a union power set of a. So here ask a union power set of a. So here we need to first find out the power set of a. Okay, so a contains, there are two elements phi comma b. There are two elements. So how to find out the power set? Power set a equals to power set, the total how many elements which are in power set a. So how to find out the number of elements in power set? 2 raised to n. N means total number of elements in a set. There are two elements, 2 raised to 4. So how many elements which are in power set a? 4. Phi which is a subset of every elements, every sets. Okay, next, first element phi, so write down every elements which are the subset of those set. Second elements b, and third is combine phi comma b. Okay, braces complete. So this is a power set. Okay, next, this is a power set. Here already you have find power set of a. Okay, now see here. So now a union power set of a, that means A, phi comma B braces complete union phi in braces phi braces B braces complete phi comma B braces complete. Okay, so here to find out the union means all the elements of A set, B set and common elements consider one time. Okay, so equals to in braces phi. Okay, phi, these elements belongs to both sets, so consider one time. Next, second element B, here B is not present, so write down your B. Okay, next in braces phi as it is, in braces B as it is, in braces phi comma B as it is. Okay, so this is a union power set of A. Okay, so this is the answer, because this B and this B is different B, so that time there are different elements, so write down phi B as it is, then phi B phi. Okay, next A intersection power set of A. Okay, so here just concentrate on a this power set and A set. Okay, so A intersection power set of A means common elements in both set. Which element is common? Phi. B, there are different element here. This is a subset and this is a single element. Okay, so one element is common is phi, so answer is phi. So answer is here in braces phi is a element. Okay, when if you write power set of A equals to phi like this, that this means it is a null set, but this is not a null set which contains the one element. The set which contains one element is phi, so this is a right answer. If you write like this, so it is a wrong, so write like this. Okay, so next example, state whether true or false. Okay, in braces phi belongs to in braces phi braces complete. Okay, this set, this is a set. Okay, phi in braces phi. Okay, and here this set contains braces phi. Okay, these elements which are belongs to this set, so true. So this statement is a true, contains the elements phi. This set contains the element in braces phi. Okay, second, phi subset of phi is subset of in braces phi. What is the answer for this question? Phi means it is a null set. It is a null set. And null set, empty set, which is a subset of every set. Empty set, this is a null set, not a element. Phi means here, because single phi written here, so that means it is not a element, it is a null set, empty set, and every empty set is a subset of every set, so this is a true condition. Okay, next, in braces phi braces complete belong subset of in braces phi. Okay, so here this set contains the phi, not elements like this. This is a set contains phi, but here braces phi, this is a one elements. Okay, this is a one elements. That means this condition is false, because this is another elements and this phi not equals to in braces phi, two different elements here. This set contains single phi elements and this set contains braces phi. Okay, so that means there are different elements, so that's why, so this condition is false, this statement is false. The only elements of this set is 5 and not 5. Okay, so same way you can solve this example to use the logic. Okay, next, second example, state or false. In braces, phi equals to phi equals to phi. What is the answer for it? Is a true or false? False, because this is a set. This set contains a phi, and only phi is a null set. How it is possible? Because this set contains a 5 elements and this is a null set. So how it possible that this set is equals to 5? So it is a wrong, means false condition. This condition is true. In braces phi not equals to phi, because this set is not a empty set. It contains one single element, is phi. Okay, so phi stands for an empty set. In braces phi is not an empty set, as in it contains one element, namely phi. Okay, so same way you can solve the number of the examples. So in this subject, practice is more important. When you solve the more number of the questions, so that times it is easy and it clear your concept and you can solve the fastly. Okay, and your means your logic also improve. Okay, next is law of the set theory. Laws of the set theory. There are some laws which are used in discrete mathematics. Okay, so there are 6 laws. First law is commutative law. First law is commutative law. Commutative law means suppose A union B. So by using commutative law, you can write B union A. Both are equal. A union B equals to B union A. By using commutative law, we can change the set positions or place. Okay. Second, if we have A intersection B, that means we can write B intersection A. Okay, just changing the place of a set. Okay, but the operations or operator remains same. Okay, next, second law is associative law. Associative law, first example is A union B union C. If this is given, by using associative law, we can write A in bracket A union B union C. Okay, by using associative law, we can write, if the given A union in bracket B union C, so that time we can write by using associative law in bracket A union B union C. Okay, if this types is given A intersection B intersection C, that time we can write A intersection B bracket complete intersection C by using associative law. Okay, next, by using distributivity law. Okay, so what is given in distributivity law? First, if A union B intersection is given, so that time we can write A union in bracket B intersection C, we can write A union B intersection A union C. A intersection B intersection A union C. Okay, if given A intersection B union C, we can write this statement, both are equivalent. Okay, A intersection B union A intersection C. Okay, both are the equivalent to each other. So by using associative law, we can write this statement as this statement, same as these statements. Okay, next, fourth law is for idempotent law. Idempotent law. Okay, if A union A, so that's we can write A, because same set union with same set, so the answer is A. Okay, if A intersection A, that times we can write A, we consider as A by using idempotent law. Next law is absorption law. Next law is absorption law. Suppose is given A union A intersection B. Okay, so it is equivalent to A union A equals to A. Okay, suppose for example, how it is possible. Okay, how it is possible. Okay, so here suppose A intersection B. Okay, and so A intersection B union A. Okay, so suppose here we consider A intersection B means we can write these statements as A union A. Common elements in both set. Okay, so that time answer is A. Next, second, A intersection A union B. Answer is A, because so here any set is comes here. Okay, suppose A or B. Okay, but here use A. Okay, so A intersection common elements in both sets, so answer is A. Okay, so by using this absorption law, we can prove by using Venn diagrams on truth tables. Okay, so next, De Morgan's law. Suppose A union B complement, we can write these statements equals to A complement. Okay, A complement separate, union complement, answer is intersection, and B complement as it is. Okay, this is both are the equivalent statements. Next statement is A intersection B complements. To write down the equivalent statement of this first statement is A complement as it is, intersection complement is union, and B complement as it is. Okay, so this is the equivalent state, both are the equivalent statements. Okay, this is a De Morgan's law. Okay, so now we will see the examples and to prove the De Morgan's law. Okay, first example, prove the De Morgan's law for any two sets. Suppose here De Morgan's law is, we need to remember to keep all these laws in mind. Okay, so because in exam there is no given any statement A union B complement equals to A intersection A complement intersection B complement. This is the De Morgan's law. Okay, so in exam ask only to prove the De Morgan's law, the statement is not given. Okay, so to in exam ask also for what is by associations. So write down something about the association. What is the idempotence? To prove the idempotence, so you need to remember everything. What is by idempotence? And also you need to remember the every statements of every law. Okay, so here prove the De Morgan's law for any two statements. Okay, so we know what is by De Morgan's law. First is A union B complement. Okay, equals to A complement intersection B. we need to prove these things. Okay, how to prove? If suppose if X belongs to A union B complement. Okay, here see here. Okay, so here if X belongs to A union B complement. Okay, what do you mean by X? Means X is a element. So you have consider, suppose X is a belongs to A union B complement. Okay, so next, second things, if X the elements which are in which are the this is the element which are belongs to A union B complement, means that means X not belongs to A union B, because A union B and A union B complement both are different. It contains a distinct elements, different elements. Okay, so that means X not belongs to A union B. Okay, so next, X not belongs to A, that means X not belongs to A, because which are belongs to A complement. So we can write X not belongs to A and X not belongs to B, because X belongs to B complement. Okay, so next we can write X belongs to A complement, yes, and X belongs to B complement, yes. So write down next, that means X belongs to A complement intersection B complement. Intersection B complement. Okay, because here X belongs to A complement and X belongs to B complement. That means X belongs to A complement and means intersection. And mean intersection. Okay, and B complement. So the LHS equals to A union B complement, and final answer RHS, right hand side, equals to A complement intersection B complement. So both are proof. Okay, second is second law, A intersection B complement equals to A union B complement. Okay, so how? So now we are going to prove the second law of De Morgan's law. If X belongs to A intersection B complement, so here write OR. Okay, so X belongs to A intersection B complement, that means X not belongs to A intersection B, because this elements belongs to A intersection B complement, not belongs to, that means not belongs to X not belongs to A intersection B. So we can write same things as a X not belongs to A or X not belongs to B. We can write same. So next we can also write X belongs to, same things we can write in the form of A complement. X belongs to A complement, yes, or X belongs to B complement. Okay, that means we can write X belongs to A complement union B complement. So write down here, not a or, so not a and, we can use, we should be use or, because here or means union. We have used here U means union. Okay, so that time, that's why we should be use or here. Okay, so by the same way we have proved the De Morgan's both law, LHS equals to RHS. Okay, so this type of questions most of time asked in exam. So this is the important questions. Okay, so next examples on a, this is some note. There are two also De Morgan's law. It may be noted that the De Morgan's law can also be expressed as A minus B in bracket B union C. It is equivalent to A minus B intersection A minus C. We can express as, okay. And second De Morgan's law, A minus B intersection C equals to A minus B union A minus C. Okay, so now we will solve the next examples on a Venn diagram. Okay, thank you all of you.